Today's lecture is on ballast. So what is ballast? Ballast is a granular material, usually broken stones, okay, a gravel or sand placed and packed below and around the sleepers to transmit the load, okay, due to the wheels or train from the sleepers to the formation and to the same time allowing the drainage of the track. So you can see here, these are the rails and these are the sleepers, and this is the ballast layer. Okay, as you can see in this figure here, this is the ballast layer. So ballast is the layer of the broken stones, gravel, muram or any other granular material placed and packed below and around the sleeper. So this is the sleeper and this is the ballast layer which is placed below the sleepers. So it distributes the load from the sleepers to the formation. Okay, so it provides a suitable foundation for the sleepers and also holds the sleepers to their correct level and position, preventing their displacement by lateral or longitudinal thrust. So the lateral stability of a track depends on the ballast. So what is the function of the ballast then? Let us see the functions of ballast. So it transfers the load from the sleepers to the subgrade and then distributes it uniformly over a larger area of the formation. It holds the sleepers, ballast holds the sleepers in position and prevents the lateral and longitudinal movement due to dynamic loads and the vibrations of the moving trains. So it also imparts some degree of elasticity to the track. It provides, okay, it will provide easy means of maintaining the correct levels of the two lines of a track. So it would also provide good drained foundations, right, immediately below the sleepers and helps to protect the top surface of the formation. So it provides a level and hard bed for the sleepers to rest on, and it will provide, the ballast will provide the necessary resistance to the track for longitudinal and lateral stability. Then let us see the requirements, okay, requirements of a good ballast. So what are the different requirements of a good ballast? So to perform the functions, the ballast should have the good requirements. So what are these requirements? So it should be able to withstand hard packing without disintegrating. So in other words, we can say it should resist crushing under the dynamic loads. Then it should not make the track dusty or muddy due to the powder under dynamic wheel loads, but should be capable of being cleaned to provide a good drainage. Okay, then it should allow for easy drainage with minimum soakage, and the voids should be large enough to prevent the capillary action. Then it should offer, okay, the ballast should offer a resistance to abrasion and weathering. So abrasion, what is abrasion? Abrasion means wear due to rubbing action, right? Abrasion means wear due to rubbing action of the particles with each other. And weathering, what is weathering? Weathering means cracking and shattering of the material due to variations in temperature. So it should generally be cubical. The ballast should be generally be cubical with sharp edges. Then it should be non-porous and should not absorb water, right? A good ballast should be non-porous and should not absorb water. Then it should retain its position. Ballast should retain its position laterally and longitudinally under all conditions of traffic. Okay, then the ballast should be able in nearby quarries so that it reduces the cost of the supply. So the size of the stone ballast, okay, should be 5 centimeters for a wooden sleepers, 4 centimeters for metal sleepers, okay, and 2.5 centimeters for crossovers. So coming to the size of the ballast, let us see the size of the good ballast. So the ballast size for wooden sleepers is 5.1 centimeters. For the steel sleepers it is 3.8 centimeters, and for ballast size for under switches and crossings it is 2.5 centimeters. Then there are different types of ballast. Okay, so we have the broken stones, then we have the sand, Muram. Okay, so broken stone is the best material for the ballast. Okay, and almost all the important tracks are provided with stone ballast. So broken stone satisfies all the specifications and requirements of a good ballast. So the best stone for the ballast is non-porous, hard, and angular. Okay, it is angular, which do not flake when broken. So igneous rocks such as a hard trap, okay, quartzite and granite make excellent ballast and are used in large quantities of high speeds tracks in India. So where such hard stone is not available, okay, so sandstone and limestone, which make fairly good ballast, are used. So for stability, graded broken stone ballast is better than the ungraded one. So graded stone of 5.08 centimeters and to 1.9 centimeter size is found to provide the maximum stability. Okay, on the other hand, like workability is better with small size ballast, say 1.9 centimeters. Then coming to the minimum depth of the ballast section. Okay, so as you can see in this figure here, this is the slipper spacing which is provided. So the size and section of the ballast, as I told you, the size of the ballast will vary from 1.9 centimeters to 5.1 centimeter. Okay, so the minimum depth of the ballast section, although the lines okay, of equal pressure in the ballast to the wheels of the loads are in a shape of a bulb. So as you can see here, the slipper spacing equals to the width of the slipper plus 2 into depth of the ballast. Okay, or you can say S equals to W, that is the width of the slipper, plus 2 into dB. What is dB? Is the minimum depth of the ballast section. Okay, that is dB equals to S minus W upon 2. So these are the different, it's a table showing the dimensions or the width of the ballast, that is 3.35 centimeters for a BG, and for MG, that is the width of the ballast is 2.25 meter. Okay, and for NG it is the width is 1.83 meters. Okay, so the coming to the depth of the ballast for a BG, it is 20 to 25 centimeter range. For an MG it is 50 to 20 centimeter, and for NG it is 15 centimeters. Then coming to the quantity of the stone ballast per meter length, that is 1.036 meter cube. Okay, whereas for an MG it is 0.71 meter cube, and for an NG it is 0.53 meter cube. Then coming to subgrade and formation, let us understand what is subgrade and the formation. Okay, so the subgrade is nothing but the naturally occurring soil, okay, which is prepared to receive the ballast. So the selection of the soil for the subgrade is not entirely within the engineer's control. Okay, so a railway track extends over a very long distances and different varieties of soil are likely to be encountered. So he is forced, okay, the engineer is forced to use the subgrade available. If he is equipped with the knowledge of the elements of the soil mechanics, he will be able to make the best use of the available subgrade, okay, using other materials. So the prepared flat surface which is ready to receive the ballast, sleepers and the rails is the formation. So as you can see here, this is the formation, the subgrade. Okay, these are the rails here, this is the sleepers, and these are the ballast. Okay, so with this I think this is clear. So the formation is an important constituent of the track as it supports the entire track structure. So when the formation is in the shape of a raised bank constructed above the natural ground, it is called as an embankment. As you can see here, this is the embankment. So when the formation is in the shape of a raised bank, okay, when it is a raised bank, it is an embankment. Okay, the formation at a level below the natural ground is the cutting. Then this is the formation width as per the Indian standards. So for an embankment, okay, the width of the bank, that is single line, for a BG it is 6.1, for an MG 4.88, and for an NG it is 3.7. Okay, similarly for double line it is 10.67, and for a BG, and for an MG it is 8.53, and for an NG it is 7.32. Okay, whereas for a cutting, that is the single line for a BG, it is 5.49, mg it is 4.27, and for an ng it is 3.35. so this table is very important. This is as per the Indian standards, okay, that is for an embankment and for a cutting. Coming to the various functions of subgrade, so let us understand what is the function of the subgrade. Okay, so the formation of a track is obtained by either constructing an embankment or providing a cutting. Okay, so the height of the embankment and the depth of the cutting depends upon the topography, that is the ground contours, and the gradient, right? So the top layer of the embankment or the bottom layer of the cutting has to stand up to all the loads coming on the track. You can see here it should withstand the track loads. The subgrade material performs the various functions, like it should bear the moving loads transmitted to it through the ballast with as uniform as reaction as possible. So it should prevent the ballast from puncturing into it. So it also facilitates the drainage. Okay, that is, it should drain the drain off the water entering from its top. Okay, then it shall provide a smooth, uniform, regular and graded surface on which the ballast and the track may be safely laid. Then it shall not change its volume due to variations in moisture, as it will create stresses on the track material and disrupt the track. So we can say it shall provide provides stability to the track. Okay, so it shall provide a smooth, uniform, regular and graded surface on which the ballast and the track may be safely laid. Okay, and it shall not change its volume, as I told, due to variations in the moisture, as it will create stresses on the track material and disrupt the track. So what are the observations made for the systematic and scientific study of the subgrade soils? Let us see this. So subgrade, the various observations are made. So what are these observations? So the subsoil surface of the entire length of the track to collect data for soils and foundations should be made. Okay, so all the data for soils and foundations should be made. So the subsoil surface, a survey of the entire length of the track, okay, to collect data for soils and foundations should be made. Then the various characteristics of soil. What are the different characteristics of soil, such as moisture content, unconfined compressive strength according to Atterberg limit, chemical composition, density and shearing strength should be studied by conducting the laboratory tests. Okay, then the level of the underground water should be determined, as the groundwater may be the cause of unstable formation. So the best choice of the material for the subgrade improvement is the better soil obtained from the borrow pits in the nearby land, or by importing a better type of material and providing a layer of the same between the ballast section and the subgrade. Okay, so proper drainage also improves the subgrade. So the best choice of material for embankment should be dense, free from excessive moisture, okay, high in internal friction and cohesion, possessing low compressibility, okay, and low capillarity. So soils which are low in internal friction and cohesion tend to flow or spread out, especially when there is excessive moisture. So if highly compressible, okay, the bank continues to settle down under traffic. So low capillarity tends to keep the formation free from excessive moisture. So what is the ideal material? The ideal material is the soil containing gravel, sand, clay and silt in equal proportions, with the moisture slightly above the plastic limit. So moisture between 10 to 12% of the dry weight gives a maximum density when well consolidated. Okay, so the subgrade improvement is required to prevent undue slides in the embankment after it is consolidated. So such soils, okay, usually a mixture of 2 or 3 different soils give satisfactory results. Okay, so clays in particular, like black cotton soil, or even clay soils with particles having rounded edges, Okay, they are very dangerous, right? So a contact of the soils with a contact of the soils with moisture causes them to swell, resulting, okay, it will resulting in the sloughing of the bank. So in such cases the soil has to be improved. So subgrade improvement, okay, subgrade improvement is required to prevent undue subsidence, okay, and the slides in the embankment after it is consolidated. So non-cohesive soils in the subgrade satisfy all the requirements of good subgrade, okay, and do not need any improvement, okay. But heavy clay pit soils, then loamy soils containing clay should be avoided, okay. So what are the different methods of improvement? The methods are admixtures of different soils, then subdrainage, blanket, cement grouting, sand piling, concrete mats. So let us understand each one in detail. So admixtures of different soil, okay. So the desired constituents should be brought from the scattered borrow pits and mixed together during the process of spreading on top of the bank before compaction. So sandy material should be mixed with clay soils to reduce the plasticity of the clay and to provide the internal friction. So individual soils should be mixed in proper proportions, okay. So the best material should be reserved for filling 75 meter to 1 meter of the 1 meter of the bank at the top, and practice should be to use sandy and gravelly material just below the ballast rather than the clay or silty material. So individual soils, as I told you, should be mixed in proper proportions. Then coming to subsurface sub-drainage. So what is the sub-drainage? So in this, the sub-drainage method is useful in the types of soils as sandy or gravelly, okay, underlying impermeable ones. So it does not help in the case of the clay or the silts, okay. So for sub-drainage method, trenches are excavated longitudinally a few meters beyond the toes of the formation, okay. So the cross trenches at intervals of 15 centimeters are connected to longitudinal trench. So in this trenches, the porous pipes known as sticks are laid to a certain fall with butt joints, and on its top any porous material like sand, gravel or loose rubble is filled and the drains are led to the water course. Then we have the blanket. So in this method, a blanket of non-cohesive, okay, a non-cohesive soil between the subgrade and the ballast section is used. So this will improve its bearing and drainage properties, okay. So as you can see here in this figure, this is the stone ballast, and this is the inverted filter. This is the minimum thickness of inverted filter is 30 centimeters, okay. So a blanket of non-cohesive soil between subgrade and ballast section is used. So this will improve its bearing and drainage properties. Then coming to cement grouting. So the objective of grouting is to stabilize the weak soils, right? What is grouting? Objective of grouting is to stabilize the weak soils. This is the reason we do grouting. So it is used to stabilize and strengthen the entire subgrade. So the grout consists of the cement and sand mixed with water to make the slurry. So the ratio of cement to sand may vary from 1:1 to 1:1:2. So normally there are two types of cement grouting. We have the pneumatic injection and the hydraulic injection. So let us understand what is this pneumatic injection. So in which 3 centimeters, okay, in this 3 centimeter steel pipe with a point of hardened steel having numerous holes at the end is driven by a pneumatic hammer, okay. A rubber hose of the same diameter is coupled to it, and through it a cement grout, okay, a cement grout is injected under a 4.2 kg per centimeter square air pressure. So the pipe is then withdrawn and driven at other places in the inclined direction. So the grout performs the various functions like the cement grout seams at the bottom of a pocket soil, seals off the moisture getting into the pocket, okay. So it completely fills the cracks, preventing water to flow through them. Then we have hydraulic injection. So a hydraulic pump is used to increase the pressure here. So a lean mixture of up to 1:32 of cement grout is used, and the work is continued till the grout appears to the ballast up to its top surface. So the injection points are placed at 1.5 meters to 1.8 interval in a staggered position at the top, at the both the end of the sleepers. Coming to sand piling, so in this method, okay, a series of holes, okay, of 30 centimeter diameters, as you can see here, series of hole 30 centimeter diameter are driven with a steel instrument inside, okay, and outside of the rails up to a depth of 1.8 meter to 3 meters, and then filled with clean sand, and the track is resurfaced. So these holes are driven vertically, okay, into the subgrade, okay, especially through the water or weak pockets by means of augers, okay, or similar tools, or by driving the wooden piles, okay, and then taking them out. So sand piling performs the various functions, okay, like they can function as a timber piles. They provide good mechanical support, okay, so they provide the vertical drainage by capillary rise of moisture to the surface and surface evaporation. So in order that the water from the sand piles may drain out, inverted filter as a sub base, okay, is to be provided below the ballast layer. Then we have concrete mats, okay, so precast concrete mats or slabs have been used between the ballast section and the top of the subgrade. So this is done for ensuring an even distribution of load from the ballast to the subgrade. So with this I come to the end of this lecture.